Good day, students and viewers. Like I promised in the previous video, I am going to start calculations in mass volume relationship based on those formulae that I've listed out. We're going to start simple and we'll go to the ones that seem complex. So look at this question that says, calculate the mass of calcium oxide produced when 10 grams of calcium triiosocarbonate 4 is completely decomposed by heat. Calculate the mass of calcium oxide produced when 10 grams of calcium triiosocarbonate 4 is completely decomposed by heat. Some of these questions can come this way without the equation, and some of them can come with the equation. So at your level, you may be given the equation, and at another level, you may not be given the equation. But however it is, for you to solve that problem, you need to write the equation. So we'll start by writing the equation. So we're talking about calcium triiosocarbonate 4, which is a solid, and is being heated to produce calcium oxide, which is a solid, and a gas, which is carbon dioxide, is evolved. Okay? And then they are asking you that if 10 grams of this is decomposed by heat, how many grams of this will be produced? So, first of all, you need to run to moles, because in moles, you can talk about the relationship between the reactants and the product, and that's what we'll talk about in stoichiometry. So from the equation, you can see that it takes 1 mole. Of course, before you look at your mole relationship, you need to check whether the equation is balanced. Of course, I'm starting with a simple one where the equation is already balanced. So look at calcium, an atom of calcium, an atom of calcium, an atom of carbon, an atom of carbon, 3 atoms of oxygen, 1 here, 2 here, making it 3. So the equation is balanced. But as we proceed, I will come up with the ones that the mole ratio may not be 1:1. Okay, I'm taking these simple ones for a start. So we're doing 1 mole of calcium triiosocarbonate 4 combining with 1 mole of calcium oxide, producing 1 mole of carbon dioxide. So, if we have 10 grams of calcium triiosocarbonate 4, and we already know that you can relate calcium triiosocarbonate 4 with calcium oxide in terms of moles by saying that 1 mole is producing 1 mole. So, let's find out the number of moles and 10 grams of calcium triiosocarbonate 4 as the equation stated. You can see that in the question you were given the individual atomic masses of the element involved in that compound. So which means you already know that calcium triiosocarbonate 4 is 100 gram per mole. 100 gram per mole. So because it's 100 gram per mole, we can now bring in the first formula that I have there, which is number of moles equals to mass over what? Molar mass. Molar mass. Why are you doing this? You want to know the number of moles in 10 grams. Okay? So you now say 10 over 100, and that will give you 0.1 moles. Now, from the stoichiometry, you already know that 1 mole of calcium triiosocarbonate 4 is producing 1 mole of calcium oxide. So 0.1 mole will also produce what? 0.1 mole. But the examiner is asking you to find the mass of calcium oxide produced. It's not asking you for mole. You have gotten the mole. So what next are you going to do? You now say mass of calcium oxide produced. Mass of calcium oxide produced will now be number of moles of calcium oxide times its what? Molar mass. Of course, you can see I am doing that from this relationship where I have number of moles equals to mass over molar mass. Therefore, mass will be equals to number of moles times molar mass. So if I do that, I already know my number of moles is 0.1. I can say 0.1 times. Then what's the molar mass of calcium oxide? Of course, from what you see in the question there, the atomic mass of calcium is 40 and that of oxygen is 16. So we're talking about 40 plus what? 40 plus 16. And you know that will be 0.1 times 56. And we have 5.6 grams. That will be the final answer. So in the question, it means that for every 10 grams of this decomposed, you are producing 5.6 grams of calcium oxide.